Hey guys, in our third day of notes, we are going to talk about what to do when we don't know the angles and how to find those angle measures given some sides. So, I talked to you in our last set of notes about how the tangent and the angle measure and the sine and the angle measure and the cosine and the angle measure were kind of glued together. You can't just separate them. But there is a way to separate them, and you may have noticed this button on your calculator. It is the inverse of each of those functions. So inverse means doing the opposite. So if we take the inverse of our tangent, we can get to that angle measure. And I want you to notice here with the inverse tangent, we have the tangent of A equals X, and then they switch places. The inverse tangent of X equals the measure of angle A. So really what we're doing is taking the inverse to both sides and it's canceling out. We're going to talk about that in class. But I'm going to show you what this process looks like when you're solving on your homework. So find the measure of angle A and the measure of angle C to the nearest tenth of a degree. And when we find the measures, we're going to do them both using our trig functions just so we can practice that. So let's start with finding the measure of angle A. So first thing, as always, I'm going to write SOHCAHTOA up top. So if I start at A, I have opposite is 16 and I have adjacent is 20. Opposite and adjacent are tangent. So I have the tangent of my angle measure, and in this case, that's A. We don't know it. Is equal to opposite over adjacent. Now, this isn't something where I could put it over 1, cross multiply, and find the answer, because we need to get to this unknown A value. So to do that, we're going to take the inverse tangent. So I'm going to get the measure of angle A is equal to the inverse tangent of 16 over 20. So I'm taking the inverse tangent of the other side there. And then you type inverse tangent of 16 over 20 in your calculator. And so you will get the measure of angle A equals 38.7 degrees. If you're not getting that, it might be because your calculator is in the wrong mode. You'll need to change it over to degree mode. If you need help with that, come in and see me. All right, then I'm looking at angle C. So in angle C, I have the opposite and the adjacent again. So I'm going to use tangent again. I have tangent of angle C is equal to, this time opposite is 20, and adjacent is 16. So that ratio has flipped over. So now I get the measure of angle C is equal to the inverse tangent of 20 over 16. So the measure of angle C, I'm going to type that into the calculator, is 51.3 degrees. Now, if you had added 38.7 and 51.3, you should get 90, because then we have our angle B is 90, and our whole thing has to add up to 180. But it's good for us to practice it this way rather than just subtracting. That's a good check for you. Okay, so then I'm going to start again at angle A here. So from angle A on number 2, I have the opposite is 14, and I have the hypotenuse is 26. So opposite and hypotenuse is sine. So I have the sine of angle A is equal to, the opposite is 14, hypotenuse is 26. So then I have the measure of angle A is equal to the inverse sine of 14 over 26. So it changes to inverse when it changes sides. When we peel that sine away and move it to the other side, it's the inverse sine. Again, we're going to talk about how that really works in class. So the measure of angle A is approximately equal to 32.6 degrees. All right, let's try C now. So from point C, from that angle, I have adjacent is 14 and I have hypotenuse is 26. So adjacent and hypotenuse is cosine. So the cosine of C is equal to adjacent over hypotenuse. So again, the measure of angle C is equal to the inverse cosine of 14 over 26. Put inverse cosine of 14 over 26 in your calculator. The inverse cosine is approximately 57.4 degrees. Let's practice one more of these. So it says solve the right triangle, round decimal answers to the nearest tenth. Okay, so a couple different ways that you can solve this, and so we want to find the length of AC, the length of BC, and we need to find that angle B. So one way to find angle B would just be to add up all of the angles. So we have, if we know that's angle C is 90, we could just do 90 minus 23. So we get 67 degrees is angle B. And that would help you then to find the other side lengths. So if I know, I'm going to write SOHCAHTOA at the top again. So then I have just the hypotenuse, and I'm going to look at angle A. You could look at angle C instead. But I have just the hypotenuse, so I'm going to do this. I'm going to find side AC. I'll call it X. So if I'm finding AC, then I have adjacent and I have hypotenuse. So adjacent and hypotenuse would be the cosine. So the cosine of my angle is equal to adjacent over hypotenuse. Now look, the x isn't with the cosine. We're back to this cross multiplying to solve. So we get x equals 40 cosine of 23. So x is approximately, type that into your calculator, and you should get 36.8 feet. It says round to the nearest 10. So that is AC is approximately 36.8 feet. And then if we do BC, I'm going to call it Y. So I have opposite is Y, and then I have hypotenuse is 40. So opposite and hypotenuse is sine. So I have the sine of 23 is equal to Y over 40. I'm going to put it over 1 again and cross multiply. So Y is equal to 40 sine of 23. And if you type that into your calculator, 40 sine of 23 should give you 15.6. So then BC has an approximate length of 15.6 feet. Okay, that's all we are going to cover for today. So if you have questions, come in and see me. I will see you in class.